sin I alpha. So now, what this verse says basically is r sin I plus 1 alpha minus r sin I. Difference is delta I plus 1. So delta I plus 1 minus delta I is this. This is called a second order difference equation. And is the most optimal way of handling the signs and finding the signs. In fact, this is amount to, not exactly, but amount to the differential equation. Roughly speaking, I am not saying that Aryabhata have no differential equations. This will be equivalent to that. Okay? So physics students, you have already been doing triple harmonic, right? Huh? Triple harmonic means sine t, and this thing is sine of this thing omega t will come, right? So that is precisely satisfy this differential equation. D square to dt square sine square omega sine omega t is equal to minus omega square. So that is kind of same thing here essentially. So this is equivalent to that. I am not saying that. And it is the best way of. In fact, some 4.5 years back, we had some series of lectures in Chennai Mathematical Institute on history of mathematics, history of calculus in India and Europe. So one American mathematician had come, David Mumford. He is a Fields Medalist. Fields Medalist is very high honor, you know. It's like Nobel Prize. Nobel Prize, there is no Nobel Prize in mathematics. And Fields Medal is equivalent to Nobel Prize, maybe even slightly higher, because Fields Medal is given only once in 3 years. He is a Fields Medalist once in 4 years. Yeah. So a very important mathematician. He was also gave a talk, and he was really, in his talk he said that he was really extremely impressed by this Aryabhata's formula. See how Aryabhata has done it and how it is the most optimal way of doing this. So in fact, it is inspiring to go through Aryabhata and mathematics in India. So this is the thing. In fact, these values of the 24 odd signs themselves are explicitly noted in another one. So they will give the values also. Okay. So in the this thing notation, Aryabhata's notation, which was mentioned by the previous speaker. So the values will be written as Maki, Bhaki, Daki, Paki, kind of a thing. It will all, denote certain number, 225, 224 like that. The exact recursive relation is given by this. In fact, not r sin I alpha by r sin alpha, r sin I alpha 2 into 1 minus cos alpha. So the difference will be slightly not too much. So 2 into 1 minus cos alpha is that 0.0042, that is 1 over r sin alpha is this. So these are the construct designs. Of course, they are given some other methods also. In fact, later, this kind of difference equation was used in a particular manner. Later in Kerala, a lot of important developments took place, and in mathematics and astronomy, especially mathematics, somewhat calculus concepts were developed there. So in Madhava in 1340, 1350, around that time, and in Paroyas. And in fact, the first time they gave the infinite series. These are essentially the Taylor series or declining series for sin theta. Sin theta is equal to theta minus theta cubed by factor of 3. Essentially using this difference equation method, of course more sophisticated versions. So there is a continuity. Because they all thought themselves as, Aryabhata. So they gave this sin theta as this infinite series. First time infinite series was, discovered in 14th century, whereas in the Western European countries, they come around 17th century. So 3 centuries earlier. And of course that infinite series was tan inverse theta. So up to and including theta to the power of 11 term used by Shankaracharya to construct sine table, he has done that. So he attributes the result to Madhava, and how good is the accuracy? So this is the table. How much time do you have? Okay. So I will be winding up in 5 minutes. So it's a theta in minutes, okay, that is 1 degree by 60, right? So 225 minutes, Aryabhata value is 225. Then there is one Govinda Swami. So he gives around He comes around 9th century or so. He used the value 224 plus 50 by 60 plus 23 by 0. Read it like that. So you have to divide by 60. Whereas Madhava's value, as noted by Shankaracharya, it comes to be 224, 50, 22. But the same as modern value. Okay? So what I am saying is this is equal to, this is 23438 into the sine of this angle. Okay? So that is given by that. So similarly, so you can see that, of course, Madhava's values, which uses the infinite series up to the theta to the power relevant term, that is very accurate. And Govinda Swami's result also is fairly accurate, and Aryabhata's result is, considering that, it was the first attempt, so it is fairly good, very good, I would say. Only in the last things it is. So these are the sign formation discussed in. Okay. So now, in the Bhaskara, one of the first commentators on Aryabhata, he wrote a comment in Aryabhatiya, okay? So it is Aryabhatiya Bhashya. So because he explained all the things. So of course commentary doesn't mean just explaining, it also will go beyond that. Okay? Some more new things will be given. So in that, he has given a very interesting formula for r sin theta. Okay? So he has given this formula. So r sin theta is equal to r into 180 minus theta into theta divided by 40500 minus 180 minus theta into theta, whole thing divided by 4. That's the divisor, where theta is in degrees. Or if you want theta in radians, so there is a formula, 4 into pi minus theta into theta divided by 5 by 4 pi square. So it's very amazing, that it is a very simple formula. See, because sine is something, see, so many these things have a different equation, all those things were done. So here he gives an amazingly accurate formula, just as it divides, ratio of two expressions. In fact, when you see the accuracy, so I given the first column is, the point 1 means the angle is 0.1 into 90 degrees, so then 9 degrees. Second is 8 degrees like that, you see, up to 90 degrees. Okay? Sine of theta using a calculator or any computer. So you get that. Bhaskara formula gives the third column. And the last thing is percentage error. So percentage error means Bhaskara value minus modern value divided by the modern value into 100. So percentage. So the 1%. So in fact it becomes better when theta goes, theta increases to 0.43%. So it is like that in a very, very accurate.
Just around the extremes it
Little this, yeah. Little this. But otherwise,
Bhaskara in his Aryabhatiya Bhashya mentions that Aryabhata is indicating this formula,
yes, exactly.
which means he thinks that Aryabhata knew this formula.
Exactly, yes, yes. So Aryabhata, Bhaskara has mentioned that Aryabhata himself knew this formula. So these, in fact, when you plot it, you will see that, in fact, I have plotted two the things, there is no difference. I have plotted both the things using Mathematica, both the Bhaskara formula and the modern side. Okay? So it is essentially, there is hardly any difference. And in fact, I took a smaller range to get more, There also there is small, slight difference there, because I have made the range to be small, so that, it goes from 0.82 to 0.94. That is a very small. So this is the kind of things, algorithms, there are plenty of them in Indian astronomy and mathematics. Lot of these nice shortcut formulas, which are, very, so the sign thing will come in your text. But anybody without knowing trigonometry also can do that. If you using this formula, when you can calculate the position of planets without knowing too much this. So Indian mathematics and astronomy are very algorithmic in nature. So algorithms are given, you see. And this way of doing, sine and cosine and all that, is in fact particularly convenient for calculation. See? In fact, if you read Aryabhata also, you will know. I mean, if you spend a little bit of time, you will know how to calculate the positions of planets. Try to do that with Ptolemy's this thing on this. It's impossible to find out what exactly he's saying. There's such great detail he's saying, to find a chord and then arc and then find a chord and this and that. Whereas here straight away the formula are given, even tables. So that is the so evolution after Aryabhata, I will not mention that. So Aryabhata itself is extremely cryptic. Considering the fact that Aryabhata is very brief, there was need to explain its contents in the commentaries. Bhaskara was the first to write a commentary called Aryabhatiya Bhashya. He also wrote independent works for Mahabhaskariya. So these are 7th century, 620, 640 like that. There's continuous evolution in mathematical astronomy with innovations, improvements in procedures, parameters, new concepts, etc. So Brahmagupta, Bhaskara 1, Brahmagupta, Manjuda, Bhaskara 2 are some of the important names. Then Kerala emerged as an important center for mathematics and astronomy during 1350, 1600 with important innovations in planetary model initiated by Parameshwara and formulated clearly by Nilakanta Somayaji. So this has already been done, so we learned Yukti Bhasha is one of the things. So this is a planetary model which is mentioned by Professor Srinivas. So Earth is there, and what it implies is that all the planets goes around the sun, which itself goes around the Earth. So these are like the model of Tycho Brahe, something like that. So interior planets you can see Mercury and Venus. Okay. So as I mentioned, Tayoho Brahmana Buttaihi Na Bhuhu Kavali Priyate. So that means their orbit, Earth is not circumcised by their orbits. So that is how it is. In fact, that is what made him go through, because of the analysis of the longitudes and latitudes of their planets. That is what made him give this model. So similarly, basically Indian astronomy is algorithmic in nature, and aim is to reduce everything to a few algebraic trigonometric formulae and tables, so that people can straight away get into calculation, And different categories of astronomical works are there. Siddhantas, which are theory, quite a bit of theory. Tantras, which are less theories. Karanas, which are even less theory, more tables and shortcut procedures. Vakyas, only tables in verses. So this can be used even by people not knowing anything in astronomy and mathematics to calculate positions of planets and eclipses and so on. So it is because of Kannada Vakya tradition that Panchanga making was so prevalent. But of course all the later works are not so brief as Aryabhata. Aryabhata, of course, is an extreme example. It is got only 121 verses. So Tantrasandra, for instance, is a major work which he was involved in translating that. So that is got about 420 verses. So many others have about 800, 1000 verses and all. They are more elaborate. They will give more detail. But certainly they are more algorithmic, and some amount of commentary reading is necessary to understand it. Fully, the constant updating of parameters and the flexibility of approach, so new ideas can be accommodated. So that is how Nilakanta, for instance, revised the model without making too much fuss. There is steady improvement in mathematics. So for instance, the earlier timetable to infinite series is a very big step, and the commentaries are indispensable for full understanding. So Aryabhata, so to summarize, Aryabhata was the first text of mathematical astronomy in India, and all the others were essentially followed the same pattern. So they were more elaborate, more detailed. So same framework has been used by the later astronomers. So thanks a lot for your patience.
valuable speech. Any questions or doubts from the student side?
Doubts, comments, criticisms, that's all allowed.
No. She is going to ask you. She is not asking the question. Just she.
Then I will ask you question.
आवामध्ये किञ्चित् विषयानि कथयितुम् इच्छामः.
Good afternoon to one and all of us here. We have come here to talk on the topic of Aryabhata's contribution to our nation.
Our information about Aryabhata and his contribution to our nation is not anything new to you, because dignitaries who took seminar today about Aryabhata and his works explained with great interesting facts elaborately. So, keeping their valuable points in our mind, we also want to present our speech in our own style. Okay, who is Aryabhata? What do you know about him?
He is a mathematician and astrologer. He was born in Patna 476 AD.
Okay, what is his first mathematical astrological work? It was the book named Aryabhatiya, which was named after him. And an interesting fact is that it was written by him only just when he was 23 years old.
Oh, what a genius. He had got this mathematical fiction. He had that this mathematical section of the book deals with an alphabetical numeral system, that methods of solving simple and parallel equations, and intermediate equations of the first degree, sine and cosine functions in trigonometry, and rules for computing the sums, natural numbers, the squares and cubes. Is it right?
Yeah, you are right. Not only that, he was the first man to give an approximate value of pi. That is, not only that, he was the first man to give an approximate value of pi, that is 3.1416 up to 4 decimals. In the book Aryabhatiya, there are 121 shlokas. These shlokas consist of arithmetic, geometric, trigonometric formulas and algebraic formulas.
Oh, so these bricks are by him, right?
No, he just framed those formulas. After his period, many geniuses made use of his formulas. They had constructed many buildings with those bricks.
Oh, what a big formula. What is it meaning?
Coming back to the point, now I want to say the formula for pi. That is, Chaturadikam Shatamashta Gunam Dvashashti Tada Sahasranam Aidadvaya Vishkambasya Asanno Vritta Parinaka.
What a big formula. What is literal meaning?
Its literal meaning is this: add 4 to 100, multiply by 8, and then add 62,000. The result is approximate value of pi, that is 62,832, which is the circumference of circle of diameter of 20,000.
In that generation itself, Aryabhata has introduced a lot about mathematics and geography. He is also known as astronomer now. What do you know about his achievements in geography?
Aryabhata was the first Indian to postulate that Earth is round, that is Bhugolaha Sarvato Vritaha, and Earth rotates on its axis, creating day and night. Eclipses are due to shadows cast by Earth, that is Shashinam Mahaticha Bhutchaya, and then moon shines due to sunlight, and that is Chadayati Shashi Suryam.
In this view of immense contribution to astrology, India's first satellite was named after him.
And his works and discoveries are a great treasury to many of them who came after this period, and also to us now.
In this great event of seminar on Aryabhata's contribution to our nation, we are very glad to speak a few lines about Aryabhata and his contribution.
Thank you for giving us this golden opportunity.
volunteer present here. My PPT presentation is based on Aryabhata contribution of our nation. Statue of Aryabhata. The statue of Aryabhata are grounded on Pune. Introduction. Aryabhata born in 477 CE, died in 550 CE, era Gupta, religion, Indian. Major work Aryabhata, Arya Siddhanta. Birthplace Patna, big state. Main interest mathematics and astronomy. Aryabhata was the first in India to postulate that the earth is round, that rotates on the axis, creating day and night. Moon shines due to sunlight, and finally the eclipse are due to shadow cast by Earth and Moon. In view the sun's contribution astronomy, India's first satellite was named after him. All the planets, whatever moving in the orbit on its eccentric circles, moves anti-clockwise from the apophis and clockwise from the pedicles. The law was stated in 5th century AD. Much before the first law of planetary motion was given by John Kepler in 1609 AD. Distance of planet. The distance of planets from the sun in terms of Earth to sun average distance known astronomic unit 1.5 into 10 power 8 kilometers. The planet's value of Aryabhatic value and modern value. Mercury 0.375 Aryabhatic value, modern value 0.387. Venus 0.725, 0.723. Mars Aryabhatic value 1.538, modern value 1.523. Jupiter 5.16, modern value 5.20. Saturn Aryabhatic value 9.14, modern value 9.54. In ancient period, the Aryabhatic value is almost equal to the present modern value. Rotation of Earth and apparent motion of the stars. Just as a person in a boat moving forward sees the stationary object on the bank as moving backward, so the stationary stars are seen by the peoples at Lanka on the equator as moving exactly from the west. This suggests that it is Earth that moves towards the east and the stars are stationary conversely. The earlier belief that the Earth was stationary and the sun moved towards the west. The Aryabhata was the first to postulate that it is the Earth rotates and the stars are stationary. He may believe planets rotate the elliptical rather than circular. Motion of the solar system. Aryabhata described the geocentric model of solar system in which the sun and moon are each by epicircle. The order of planets in terms of distance was taken in the Earth as the moon, Mercury, Venus, the sun, Mars, Jupiter, Saturn and the Asteroids. The position and periods of the planets was calculated relative to uniform moving points. India's first satellites after name Aryabhata. India's first satellites Aryabhata and the lunar crater Aryabhata are named in honor. Thank you.
Good afternoon to one and all. Here I am here to discuss a few points about Aryabhata contribution to our nation. Already our dignitaries have explained more about mathematics. That means Aryabhata contribution to nation in mathematics. The best period of Indian mathematics was 400 to 1200 AD. Important mathematical work was done by Aryabhata, though many peoples were also enrolled in those periods like Madhava, who was a great Kerala mathematician. Aryabhata, 470 AD, wrote his famous work Aryabhata in 499 AD in Kusumagura near Patna. Aryabhata gives the details of another alphabet numerical order. We know that the alphabet consists of vowels and consonants. Here the Aryabhata, the men, has given even the numerical factor also consists of the consonants and the vowels. He describes that the name Ka, Cha, Tha, Tha, Pa were enrolled into the classical from 1 to 25. He mentioned those terms were like a consonant. The terms including the 30, 40 to 50, 60, include 90 has the vowels, that means non-consonant. already the sir has discussed about the pi value. The pi was used in all the measurement of a circle, spheres, everything which we want to shape in all the shapes. Here he discussed how to find the accurate value of pi. Though the man belongs to 400s AD, without any invention, anything, machine, everything, he was a man who has given an accurate value for pi. Even though today on this 20th century we are following the same value for pi. He mentioned that add 4 to 100 and multiply by 8 until add 62,000 feet. The result is approximately the circumference of the circle of diameter of 20,000. If you divide the value 62,832 divided by 20,000, you will get the approximate value of pi as 3.1416, approximate to 4 decimal place. Later, the Mahadeva, the Kerala mathematician, gives the value of pi approximately to 7 decimal place, and many more mathematicians have been explained the value of pi. But today we will take only accurate to 2 decimal place, that is 3.14. Trigonometry. The work done by Aryabhata in trigonometry. As many things has been discussed with Sriram sir, he tells that sin I plus 1 alpha minus sin I alpha is equal to some value. Then instead of I, they have included the n. Aryabhata, the man who has given the accurate value for sin alpha is equal to 0 to 90 degrees. That means which involves 24 steps. 24 means that means quadrant divided by 90. Quadrant means 90 divided by 24. It gives 3 degree 45 minutes. Some of this formula has been mentioned by Aryabhata. That is sin n plus 1 alpha minus sin n alpha is equal to sin n minus 1 alpha minus 1 by 2 25 sin n alpha.
Now the first term in the right hand side must be sin n alpha minus sin n alpha. The first term in the right hand side must be sin n alpha. Sin n alpha minus sin. Okay, thank you.
Okay. Next, sin square alpha is equal to 1 by 4. Sin square 2 alpha plus cosine square 2 alpha is equal to 1 by 2 1 minus cos 2 alpha. Seats of calculus. Here we know that we have a differential calculus, integral calculus, everything. This period, the calculus have been introduced. How it introduced this during the instantaneous motion of the moon. Aryabhata arrived the formula u dash minus u is equals to v dash minus v plus e is equals to sin omega dash minus sin omega. When he mentioned that u, v, w denotes the moon through longitudes, mean latitude and mean anomalogy at a particular time. And u dash, v dash, w are the same after a small interval of time. Where e is the eccentricity, we know that 1 minus b square by f a square. Algebraic formula. This formula was used today also by all of us. Even though it was invented in 400 AD, in Aryabhata provided the elegant result for the summation of the series of squares and cubes. 1 square plus 2 square plus infinity to n square, it gives n into n plus 1 into 2n plus 1 by 6. We use this formula today also in our period also. 1 cube plus 2 cube is equal to 1 into n cube is equal to 1 plus 2 plus equal to, it's go on to get the whole square. Place value system and zero. Place value system have been discovered yearly itself. Here the man named George explained that the knowledge of zero was inflicted in Aryabhata place value system as a placeholder for the power of 10 bit null coefficient. Thank you.